In this video, we will evaluate or simplify some radical expressions. If the number is not a real number, we will state this. In Part A, we are asked what is the principal square root of 49? Well, we know 7 times 7 is 49, and 7 is a positive number, so the principal square root of 49 is 7. In Part B, most people would read this as negative square root of 64. Technically, this means the opposite of the principal square root of 64. So the principal square root of 64 is 8, and the opposite of that is negative 8. So the opposite of the principal square root of 64 is negative 8. In Part C, we want to find the principal square root of 9 over 16. Since the radicand is a fraction, I assume that the answer will also be a fraction. Knowing that I'm working with a square root, I'm thinking what fraction multiplied by itself will give me 9 over 16. Remembering that we multiply fractions straight across the top and straight across the bottom, I'm really asking myself, what is the principal square root of 9 up in the numerator? And separately, what is the principal square root of 16 in the denominator? So the principal square root of 9 over 16 is 3/4. Because if we multiply 3 over 4 times 3 over 4, the 3's in the top multiply to give us 9 in the numerator, and the 4's in the bottom multiply to give us 16 in the denominator. In Part D, to evaluate the square root of the quantity 64 plus 36, we need to remember order of operations. The order of operations are normally stated as parentheses, exponents, multiply and divide, add and subtract. What we need to remember is that parentheses represents any grouping symbol. The radical symbol is a grouping symbol. We need to take care of what's inside of the grouping symbol, the 64 plus 36, first. 64 plus 36 is 100, and that must happen before we start to evaluate the radical itself. And now, the principal square root of 100 is 10. In Part E, we have the principal square root of 64 plus the principal square root of 36. While we do have some similar numbers and symbols as we had in Part D, the order of operations is significantly different. Again, we need to take care of a radical first because it is a grouping symbol, and so here we must take care of both root 64 and root 36 before we do the addition. The principal square root of 64 is 8, and the principal square root of 36 is 6. Because the addition given in Part E was outside of the radical, it will need to be taken care of after the radicals themselves. And now that we have evaluated the radicals, we can take care of the addition. 8 plus 6 is 14. It is important to always remember the order of operations and to think about them no matter what situation we're working in. And finally, in Part F, we want to evaluate the principal square root of negative 25. So the question we're trying to answer, what number multiplied by itself will give us a negative 25? We should be familiar with the idea that if we multiply a positive number with another positive number, there is no way that could give us a negative result. The other possibility then would be to multiply a negative with a negative. But again, we know a negative times a negative is a positive. Therefore, there is no real number that you can multiply by itself and end up with negative 25. This is an example of a radical that is not a real number. We don't want to say there is no solution, we will simply state not a real number. It is a number, but it is simply not a real number, meaning it does not exist on our number line. At some point in the future, you may discuss numbers that are not real numbers, but we will save that for another time.